Let's talk about digital certificates. And a digital certificate is basically a wrapper for a subject's public key. Now, as well as the public key itself, the certificate can contain information about the subject and also the certificate's issuer. Now, certificates are typically based on the X.509 standard, which has been approved by the International Telecommunications Union and standardized by the Internet Engineering Task Force. Now, over here on the right, you would see an example of a certificate. You can see the fields. You have signature algorithm, the signature hash algorithm, the issuer, the validity of the certificate, the subject, the public key, as well as the key itself down there in the big box. Now, there are attributes for certificates features. Here you have them: the serial number, you've got the signature algorithm, the issuer, validity, the subject, public key extensions, as well as the subject alternative name. Now, for the subject name itself, when certificates were first introduced, there was this thing called the common name, the CN attribute, which was used to identify the FQDN by which the server is accessed. The FQDN here, by the way, stands for the fully qualified domain name. Now, the subject alternative name, the SAN extension field, is structured to represent different types of identifiers, including domain names. Now, moving on, a wildcard domain, such as *CompTIA.org, means that the certificate issued to the parent domain will be accepted as valid for all subdomains. The point here is that if you had a website and that website has subdomains, so say for example your website is labcyber.com, right? I can have blog.labcyber.com, I can have shop.labcyber.com, and so on. If I wanted to get a certificate for all the subdomains, I could go with the wildcard certificate. Now, I want to show you right here. I'm going to give you a live example. This is from the back end of my web account with the web hosting company SiteGround. This is the SSL manager. SSL stands for the Secure Sockets Layer. It is this certificate that I can use to enhance the security of my website. When I have SSL installed, my site will run with HTTPS and not just HTTP. Now, right here you can see the domain. This is just a sample domain, by the way, alexandria49.sg-host.com. Right here, I can go with either the regular Let's Encrypt SSL certificate, which will encrypt specifically this particular domain, or I can go with the Let's Encrypt wildcard. And when I choose this one, every subdomain under this main domain right here will also have the SSL certificate as well. Now, there are different types of certificates, and certificate policies will define the different uses of certification types issued by the CA. Now, the certificate type itself, it is set by configuring the key usage attribute. The extended key usage EKU field, or the enhanced key usage in Microsoft, is a complementary means of defining usage. Now look at the image over there on the right. You will see just below the subject alternative name, we have the enhanced key usage field, and the value right there is what? Server authentication. So we know that this particular certificate is used for authenticating the server. Now, because this image was taken from Microsoft, the field there is called the enhanced key usage. Now, the enhanced key usage field can have 4 different types of values. It can have the server authentication, which we just saw. It can have client authentication, where it's the client that's authenticated. It can have code signing, or simply email protection. Now, we do have web server certificate types. Now, a server certificate will guarantee the identity of e-commerce sites in particular, or any sort of website to which users will submit data that should be kept confidential. So any kind of website that would require sensitive information from the user, maybe their credit card details or their passwords, things like that, a server certificate should be used on such sites. Now, differently graded certificates might be used to provide levels of security. Obviously, an online bank, for example, would need to have a higher security than a site that just collects regular marketing or advertising data. Now, web certificate types, we do have the domain validation DV, which will prove the ownership of a particular domain, and there's an example right there on the right. We do have the extended validation certificate type. This is subjecting to a process that requires more rigorous checks on the subject's legal identity and control over the domain. Now, we do have other certificate types as well. We do have the machine computer certificates, email or user certificates, code signing certificates, root certificates, and of course the self-signed certificates. Let's take a look at them one by one. For the machine computer certificates, sometimes it might be necessary to issue certificates to machines like your servers, smartphones, and so on, regardless of the function. And the reason is because if that machine doesn't have a valid domain issued certificate, they might be prevented from accessing network resources. This could be like a security mechanism that will say something like, hey, if this machine or this endpoint wants to join the network but doesn't have a valid certificate, they will not be allowed to do so. We also have the email user certificates. Now, an email certificate can be used to sign and encrypt messages, typically using the secure multi-part internet message extensions, the SMIME, or Pretty Good Privacy, PGP. Code signing certificates. Now, this type is issued to a software publisher following some sort of identity check and validation process by the CA. So code developers, those who would develop any kind of software, they would need to be authenticated, and this type of certificate would be used in such situations. We do have, of course, the root certificates. This one that identifies the CA itself, and it's typically self-signed. Now, a root certificate, because it's such an important certificate, would normally use a key size of at least 2048 bits, but many providers are now even switching to 4096 bits because, again, the root certificate is extremely important. And of course, finally, the self-signed certificate. Now, any machine, web server, or program code can be deployed with a self-signed certificate. The drawback here is that usually such certificates will be marked as untrusted by the operating system or browser, but an admin user can choose to override this. Thank you for watching. I will see you in the next class.